Yep, hey everyone. So this tees up well, because there's a hint just at the end there around like what you do with this information in your node that, once there's been some notion of finality, either in protocol or out of the protocol, right? There's like this stuff that never changes. And today, nodes have this like, let's get into it. Basically, this will be about history expiry. There's a particular EIP that I'll get into that suggests one, at least opens the conversation. And I think that's what we'll do today is later in the workshops around this topic, like discuss what this looks like, what it means, what's acceptable, what's not. So yeah, first like what history, kind of like I was saying just now, there's all this historical data, like the third block that ever existed. Like no one needs that block. Like it's critical, right, to the integrity of the chain, but it's like you as an application user, like user of the chain, like you haven't needed to go get that block like probably ever. Light Client actually helped me with this. We found the first transaction, I believe, in the chain. Etherscan has this nice little tooltip that shows it's from 2015. The funny thing was basically gas limit was too low, and so this was the first block where it was over 21,000, so you could send an Ether transfer. They paid 1 ETH in gas and sent, I don't know, it's like 3.1337 times 10 to the minus 10 or something Ether. Anyway, it's here, but it's like, do you need this? Like, no, you don't. Tax day was just for some of us, right? So maybe you care a lot about what happened last year, but you don't care about this transaction. Yet your node has it. And the point here is that this doesn't scale, right? Like the chain will only keep growing. That's how it works. And so what that means then is that there's this linear increase in storage, bandwidth, processing, everything, right? Granted, there's like perhaps bigger fires, right? But this will happen. And so if we care and like, if we want Ethereum to be here in like 100 years, we don't need like today's blocks. At least we don't need them to like be part of the experience of running a node. And this is what we mean by history expiry is like changing the guarantees that nodes have today such that they don't have to keep this historical state. And this is what we suggest in this EIP, 4.4s, bound historical data and execution clients. So what does it basically say? It's changing this guarantee that I keep circling around, like what history does your node have? Concretely, that is the blocks, right? So like headers, transactions, omers, for example, the transaction I showed you, receipts from execution results, these things that are critical for you to validate the chain at the time that it's sort of being appended to, the time that you extend it. But again, after a certain amount of time, that we can discuss what the right time should be. But after a certain amount of time, it becomes much less important for you to have this information on hand. And I just called out here, it does not include the execution state. I think I have a bigger, I'll just jump ahead a second to this aside. There's this whole different research topic of state expiry, right? So there's chain history, which is like, yeah, receipts and blocks. Separately, there's the state you get from executing those blocks. And the state is specialized enough that there's like a whole different research domain around how we want to handle that. When we talk about 4.4s and history expiry in this context, we mean just the blocks. Jumping back a second, like concretely, how would you do this? You just say, okay, within the P2P layer, you no longer need to serve chain data older than 1 year, for example. And this number is a parameter. We could decide what it could be. If you no longer need to respond to peer-to-peer requests for this data, then your node could prune it. You could keep it. You have freedom to do what you want. But if you are allowed to prune it, then we can delete it. Nodes are lighter. And to give you like some sense of how expensive this is, I mean, yeah, like people complain about gas cost. You all certainly know that this reflects the cost of operating a node. This was from a freshly synced Geth node a few weeks ago now, but essentially it came into 500 gigabytes, and a huge chunk of it is this ancient store. And again, this was a Geth node, so Geth devs here will be able to speak more precisely to this, but approximately, if we say drop the last year of history, I think we'd about get rid of this ancient store. And that would free up about half of it right off the bat. And why do we care? Well, again, it comes down to the cost running a node. The questions here are like, who's running a node and how are they running the node and what does it really mean to be a full node, to be an archive node. Like, we have to define what these things mean, and these come down to like Ethereum's values. So I'm sure there'll be some heated conversations later. Maybe not heated, but it can become heated because it's something that's important to all of us, right? But like at the end of the day, like this isn't sustainable, right? Again, if Ethereum's here in 100 years, we don't need 100 years of block history. And so the question's like, yeah, what can we do about that? If you do keep all this history, it becomes more expensive to run a node. You might need some specialized hardware. Then fewer people are doing it. Fewer people are actually running the protocol. Network's more fragile. Worse security. And again, this is about guarantees. Like, the actual technical implementation is like, okay, sure, like, you know, I can just snip off my database past a certain point. The thing we all need to come to consensus on is like, what do we want here? Like, what does it mean to run the protocol? What does the protocol do? This is my take, is that essentially it should be like a very secure consensus protocol, right? So the way to think about it is that there's like sort of a cursor over the recent activity, and like the output of that process is finality, right? And then once you have finality, there's like all sorts of things you can do. And the point here is that you want it to be very like focused and minimal. So like, for example, we saw a bunch of stuff yesterday around like scaling and sharding in various capacities, pushing settlement, execution, these things like to other layers of the stack. When we say the protocol, I mean the sort of L1 Ethereum protocol, and it should do this process very well. Like in particular, it's not like an archival service. You're not gonna have, you shouldn't also like have this like highly sophisticated like settlement protocol. Maybe we should just say consensus protocol. And then also like say, oh yeah, provide me this transaction from like 2015, right? Like those are different tasks. Jumping back. So if this is interesting to you, maybe you think it's a bad idea, maybe you think it's a great idea. If you are interested to explore what this looks like, there's still questions we have to ask. Essentially, like, who provides this history? Because again, it's still, I'm teeing you up. Who will provide this history? Like in a sub-question, how will it be provided? How can the history be validated? Because that's the thing, is like, just because, you know, like let's say we go into this vision of like having a superlink consensus protocol, like that doesn't mean that the history is not important. It doesn't mean the history shouldn't be available in some way. It just might be someone else's concern. And then separately, who should validate the history? That's kind of a leading question around like, yeah, what does it mean to run Ethereum? So yeah, who will provide the history? If we move into this 4.4's world, like ultimately you just need a few like reliable actors, right? Because again, it's just the data. It's like not changing ever. Going back to the previous talk, you know, there's even suggestions of like putting it on BitTorrent and like different actors just seeding it and just having this data out there. The like sort of the data, you know, the access pattern to this is like an archival use case in the sense of like, again, the data is just there once it's finalized, so it can just live forever. You don't have to like have a very sophisticated like methods to update the data and things like this. Here's some examples, right? So you could have like altruistic actors in the space. So for example, the EF could do this. I think that makes a lot of sense. I've been talking to like Filecoin just like a bit. They basically want to like put the history on Filecoin and have like a cool demo. We'll see what happens there. Portal Network, which we'll hear about I think just after this. But then other people outside of quote crypto, like the Internet Archive, there are different players where like they hopefully also think that like this history is very important and it's a public good to provide, and they could just step in and do it for free. And then yeah, just like individuals hosting torrents or different file mirrors, things like this. Etherscan and Fiera, players in the space that again are aligned and want to provide this as a public good. We could have something more experimental like a public goods DAO. Lots of ideas here. How will we get the history? This is, again, kind of implementation detail, but it's an important one because a lot of us are developers, so we like these things. You could have torrents, again, like file mirrors, data mirrors, these things like this, Filecoin, bunch of different options. How to structure it. So like the actual like syntax of the data. If we move into this world, we'll need to answer this question. We'll see a demo. The first like workshop for this after this series of talks now will be a demo around an initial exploration of this question. A cool thing would be if like we have a format that we could essentially make proofs about, and you could even then like put commitments to this data on chain. That could be fun. How can this be validated? So the vision here is essentially to have like a shim client where like you could even imagine like you could have one sort of version or cut of your client that's for one specific rule set, across forks. And then you say, okay, I'm going to run like all these different clients. You could have like a meta client that bundles them and wraps them just for ease of use. But then it says, okay, here's this huge history dump from this block to this block. Do this. Keep going fork by fork. And you could, in fact, like run every transition from Genesis if you wanted. This is here as a motivating question because, again, I think a lot of this comes down to like, what do we mean when we say run a full node? Who should validate it? Like, is it critical that everyone who runs a full node is validating the history for all time? Like, do they need to start from like maybe a recent checkpoint or something, validate from there? Do they backfill from that checkpoint if they do this? There's a bunch of different things here to discuss. And again, yeah, there's a huge design space in terms of like what your client does, what it looks like, how you answer all of these questions. So the latest work here, we have like a small working group. You can probably just DM me on Telegram if you want to get involved more directly. The IP says about what I just laid out, and at this point, I think we're just getting input from various community members. Again, this would change a lot of the guarantees of the protocol, so it's something we definitely need like wide alignment on. And yeah, Henry, who I just mentioned, who has been working on a prototype, there'll be a demo later today. And I think that was it. Yep. So yeah, hopefully we'll talk later.